The binomial theorem is a theorem that you can use to expand binomials. Binomials are two terms to an exponent. Okay? So I could expand this one pretty easy because 3a minus 2 squared means 3a minus 2. I'm so glad it's making these food boxes. 3a minus 2. Right? That's what it means. You write it out twice. Then we're going to distribute. So we get 3a times 3a is 9a squared. 3a times negative 2 is negative 6a. Negative 2 times 3a is negative 6a. Negative 2 and negative 2 is positive 4. And so we're going to get 9a squared minus 12a plus 4. How many terms did we get? We got 3. What's the connection of the number of terms and that binomial? 3a minus 2 squared. If this is a 2, the number of terms is 2 plus 1. It's always n plus 1, whatever that is, plus 1. So if that was a 7, we get 8 terms. All right. This is the binomial theorem. It is given to you on your formula sheet. Okay? It says in the form x plus y to the n, so it has to be a binomial, because that's a binomial, correct? To some sort of exponent. You can use this formula, the binomial theorem, to get any term. Okay? So, this is our formula. 3a plus negative 2 squared. Do you see how I put a plus sign in the middle? The binomial theorem states that it has to be in this form here. X plus y to the n. Do you see that? So I'm going to go x plus y to the n. So my y is just negative 2. Do you see how that sign has to go with the term? So this is my x. This is my y. This is my n. And I know because this is a 2, I'm going to end up with 3 terms. Right? So because it's small, it was really easy to expand quickly, correct? But if I want to expand 20 terms, or I want to expand something to the 20, that's going to take a long time. You might mess up, correct? So the binomial theorem is a quick way to find just one term. So if I wanted just the 10th term, I could find it like that. I wouldn't have to expand everything out, put them in decreasing, descending powers of x, and then give you the 10th one. This formula can give you any. So I'm going to show you. So we know we have 3 terms. So we're going to have to look for term 1, term 2, term 3. So the formula that we use is tk plus 1 equals nck x to the n minus k y to the k. And this looks way harder than it actually is. So our x, our y, and our n never change. Do you see how our x is x, our y is y, and our n is 2 in this case? Like, they don't change. The k changes every single time, every single term you're looking for. So here's my formula. I'm finding term 1. Right? So I'm finding term 1. What does k have to be in order to get term 1? What does k have to be? 0. Because what's 0 plus 1? 1, correct? So for term 1, k is 0. Do you see that? It's 1 less. But our x and our y and our n never change, so they're going to stay the same. And we're going to plug it in here. We're going to get t0 plus 1 equals n, which is 2, c0, x, which is 3a to the 2 minus 0, and y is negative 2 to the 0. So term 1, what is 2c0? I have two objects and I choose none of them. How many ways can I do that? One. Just stare at them. I can say, no, not choosing any of these. That's one. If you don't know, you can type in your calculator and give you a 1, right? And then we have to remember that 2 minus 0 is just 2, correct? But the 2 has to go to the 3 and to the a. Yeah? So 3 squared is 9a squared. And then negative 2 to the 0 is 1, because anything to the 0 is 1. So my term 1 is 9a squared. Cool. So if I had something with 30 terms and I wanted the second term, this would be a lot faster than expanding the whole thing out, right? Okay, let's find term 2. The formula is tk plus 1 equals nck x to the n minus k y to the k. If I want it to be term 2, what is k? 1. Everyone's writing. So we're going to get t1 plus 1. N is n. It's 2, it never changes. C1. X is 3a to the 2 minus 1. And y is negative 2 to the 1. You see how nothing changes except the k? Everything else stays the same? All right, so t1 plus 1 is t what? T2. So we're finding term 2. And 2c1 is what? 2. And then this is a 1. We have to distribute the 1 to the 3 and to the a. So we get 3a. And then negative 2 to the 1 is negative 2. And then we get t2 equals negative 12a. Because you have to multiply all your numbers. So we found term 2. And if all we needed was term 2, it would be quick to find, right? Term 3, we need tk plus 1 equals nck x to the n minus k y to the k. K equals 2. K is always 1 less than the term you're finding because 2 plus 1 is 3, right? So your k is always 1 less. So we're going to get t2 plus 1. And then n is what? Doesn't change. 2c2. X doesn't change. 3a to the 2 minus 2. And then negative 2 to the 2. So we're going to get term 3 equals 1. This is to the power of 0. What's anything to the power of 0? 1. 1. So we get 1. 1. Negative 2 squared. If you put negative 2 squared into your calculator, go do that. Put negative 2 squared in. I want to see who gets what answer. Negative 2 squared, if you got negative 4, you were wrong. Negative 2 squared is negative 2 times negative 2, which is 4, correct? So if you're getting negative 4, it's because you're not putting it in brackets. You want to go negative 2 in brackets squared, which is 4. So don't fall for that negative 4 because you didn't type it in right. So term 3 equals 4. So we have 9a squared minus 12a plus 4. Okay? Look up here. We expanded it up here. 9a squared minus 12a plus 4. Same answer. Now some might say, well, this took way longer. Yeah, because it was just squared. But if it's to the 20, and you go this to the 20, this to the 20, this, you have to do 20 brackets. Expand, 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 expand. Distribute, like, you're going to mess up. Right? Or if I give you something easier like this, it's quicker. So I want the fourth term. You try and find me the fourth term of this. X is x, y is y, n is 8. How many terms does this one have? How many terms does this one have total? If n is 8, it has 9, because you start at k equals 0 and you go to k equals n, so it gets you 9. 9, right? Do I care that it has 9? No, but they can somebody ask that question. I want the fourth one. So get me T4. Try it out, see if you do. So term 4, k equals what? What? 3, because 3 plus 1 is 4, which is what the formula uses, right? So I always fill it right into the formula. I go T 3 plus 1 equals n, which is 8, C3, x to the 8 minus 3, y to the 3. And so we get term 4, 3 plus 1 is 4. What's 8C3? 56. 56, x to the 5, y to the 3. And just so you know, these exponents should always add to whatever the heck this is. So you see how that's an 8? These turn out to be an 8 as well. If they don't end up distributing into another 1. Like, if this was an x squared, let's say, that won't, right? But like before you distribute them, here you're going to get a 5, here you're going to get a 3, which makes sense because I'm going to go 8 minus 3, which is 5, and then I put the 3 there, right? So they are the opposites until you distribute them in. Okay, third term, go. What's the catch on this one, though? My binomial has to have a what sign in between it? A positive. So this needs to be 2x plus negative 5 to the 7. So this is my x, this is my y, this is my n. Try it out. We need term 3. Term 3 means we have k equals what? 2. So that we can go t 2 plus 1 equals n, which is 7, c 2, x, which is 2x to the 7 minus 2, and then y, which is negative 5 to the 2. And so we get term 3 equals, what's 7c2? 21? 21, thank you. Then what everyone forgets, and they will have this as a common error, just so you know, is this is to the 5. A lot of people will write 2x to the 5. But that 5 has to distribute to both. And if you do 2x to the 5, that error will be one of the multiple choice answers. Okay? So we don't want that. So we have to go 2 to the 5, x to the 5, 2 to the 5, x to the 5. I'm going to write out longhand, even though I would never do this. Just showing you. And then negative 5 squared is 25, right? So we have 2 to 2, term 3, sorry, is 21. 2 to the 5 is 32x to the 5 times 25. And some people leave it like this. You can't. We need a coefficient. So everything that's multiplied, so we go 21 times 32 times 25. And what do we get? 16,000? Okay. 800. X to the 5. If I asked you for the coefficient, what would be the coefficient of that term? 16,800. It's the number that's in front. Okay? So if I ask for just the coefficient, which sometimes they do, it would be 16,800. Okay? Okay, we're going to flip over. To questions to try, please. So we're going to leave E till tomorrow. We're doing the harder questions tomorrow, so this is just the very minimum. I want you to work on these ones first, because if you can understand this really well, when I add a little bit tomorrow, it's not so bad. Just so you know, tomorrow we're done Unit 1. That's how quick it goes. Okay? So I want you to work on these